In this lecture, we are studying about the design of DFA for the language even number of ones over 0, 1. So for this problem, we need the input symbol 0 and 1. Then language should contain the even number of ones, so that even numbers are 0, 2, 4, 6. Means language contains the 0 number of ones, or 2 number of ones, or 4 number of ones, or 6 number of ones. Means the language only contains those strings which having a even number of ones. So the language is 5, means here 0 number of ones and 0 number of zeros. So we have to concentrate upon only on even number of ones. Means 0 number of ones is a even number of ones. Then second string is 0, that means here also 0 number of ones, means 0 also even number. Then two ones, then two ones with any number of 0, means 101, 110, or 011. So in the language, each and every string contain the even number of ones only. So first take the initial state, and initial state is a final state. Because of what? Phi is a part of our language. Means what? Without taking any inputs, we go to the final state, 0 number of ones, 0 number of zeros. Then if we get a 0, single 0, that string also accepted, because this string contain the 0 number of ones. Then after that, if the single one come, then machine change the state, because single one is not accepted. So that here the Q0 to Q1 is a next transaction for 1. Then when we come to the Q1 state, then for the 0, it stay in the itself only. Because of what? 10 contain the odd number of ones. So that once machine come to the Q1 state, that time it counts the odd number of ones. Then again, if at a Q1 state we get a 1, then machine go to the Q0 state, means it's to a final state. So this is complete machine for the language, which contain the Q0 and Q1 state. Q1 is the initial as well as final state. Each and every state take 0 and 1 as a input. Then let us consider the one string 101011. In that, Q0 is the initial state. So if Q0 take input as a 1, then next it will be a Q1, remaining string as it is 01011. Then Q1 take input as a 0, next state will be Q1, because there is no change in the state when the Q1 having input 0. Then when Q1 take input as a 1, change the state to Q0. Then Q0 input as a 0, then next state will be again Q0, because there is no change in the state for the input 0. Then when Q0 accept the 1, then next state will be Q1. Q1 accept the 1, next state will be a Q0, and Q0 having our final state. So let us consider the diagram for how to write the 5 tuples for the machine. So these are the 5 tuples: Q, summation, delta, Q0 and F. Then Q is nothing but Q0 and Q1, means the set of states, that's a non-empty. Then input symbol summation 0, 1. Then Q0 is the initial state, and F is and F means what? Is denote the final state, that is the Q0 itself. Then how to write the transaction? So here is a format of writing the transaction: delta in open bracket, Q0 comma 0 means what? Q naught take input as a 0, next state will be Q naught. Then Q naught take input as a 1, next state will be Q1. Then Q1 take input as a 0, next state will be Q1. Then Q1 take input as a 1, next it will be Q naught. They may this pivoters may write in the single table as well. Here the first column contain the number of state means Q, and first column contain the input symbol. So Q naught, Q1 is the number of state in the column, then Q naught is the initial state and also final state. If Q1 is a final state, then it should be denoted by the circle. Here I draw the Q1 as a final state for example. And then Q naught taking input as a 0, then next it will be Q naught. Then Q naught is in taking input as a 1, next it will be a Q1. So like this also we can write the input symbol. So thank you for watching this video.